Low-temperature plasma is a non-equilibrium electric discharge where the temperature of the electrons is much higher than the temperature of the gas. This kind of plasma is weakly ionized, wherein free electrons interact with air molecules throughout collisions, producing several chemical reactions that generate excitation and ionization of atomic and molecular species. Some of them identify as reactive oxygen and nitrogen species, also known as RONs. It has been proved by several experiments that LTP deactivates numerous strains of bacteria or bacterial spores, noting more than one inactivation mechanism attributed to the excitation of cells biological. The microorganism's deactivation capability of LTP provides bactericidal effect for decontamination on material surfaces. Moreover, LTP is able to interact with mammalian cells and tissues in non-destructive behavior. It increases fibroblast availability and mobility, accelerates healing of wounds practiced in vivo with mice, among other medical aspects. The main issue here is the way the LTP has been provided to the patient, the way the machine has been built. It is comprised of a 13.56 MHz radio frequency generator from ENI, coupled to a flexible LTP source through a homemade low-pass L-shaped matching network. LTP source has two inlets that met on a 4.8 mm plastic Y-hose connector, allowing the transmission of radio frequency signals and the gas supply. The bacterial deactivation trials consisted of two different strains of microorganisms. Both strains were prepared applying the same procedure. Each inoculated agar plate was exposed to the LTP generated in helium supplied at a flow rate of 1 LMP, and an RF electric power setup at one of three different magnitudes, 12, 14, and 16 watts. The obtained results for E. coli deactivation zones can be identified on one of the respective agar surface, as transparent semicircles of different diameters, each situated respectively at a quarter of the agar plate. The bacterial deactivation of the last two cases were effective, starting from 60 seconds of exposition time. The flexible plasma generator was characterized in terms of its electric parameters to build a homemade matching network to couple with a commercial radio frequency generator. The generated plasma emission was characterized through thermometers, an UV radiometer, and an optical emission spectrometry arrangement. The obtained OES spectrum indicates a distinctive plasma that it is in non-thermal equilibrium. The deactivation bacteria experiments were successfully accomplished, proving that the LTP generator can be used in therapeutic treatments. The dimensions of the proposed device were established, taking into consideration its possible applications like minimally invasive surgeries.